here is x, which is some position. 1/2 is just a constant, it doesn't have units. A is an acceleration, we'll learn about that more, so I'm just kind of going through it, and then t is time. And then the units for this would be, or the dimensions would be x, the position is measured in a length, right? So it's like, the position is, 10 meters from the origin, so it's a length. And then the dimensions for acceleration is a length per time squared. And so you'll see things like meters per second squared, mostly. You could also do this in like feet per hour squared, right? But you'll see a lot of meter per second squared. And then the time is obviously in time dimension, right? So that, again, would have seconds or seconds squared. So you can kind of see how these two things would cancel out, right? So you have a t squared, the time squared in the denominator, the time squared in the top, in the numerator. And so if you cancel out what these units are, making sure like, both are seconds or both are hours or both are light years, whatever, then you can cancel them out and you see that you have just dimensions of length. And so hopefully that is always the case. So if you are, if you're working through a problem, you're like, I don't know if I missed something, this answer seems like a little weird, you can look at your dimensions or, your units, which kind of go with that, right? So like a length would be measured in like a meter or something like that. So you can see to make sure that your units are what you expect them to be. They should be the same on both sides of an equation. Otherwise, you drop something along the way. So this is a nice thing to just kind of check. Even if you, don't look at all the details of what exactly is acceleration, just kind of looking at the units. And so you might, when you're doing this sort of analysis, have to convert different units, right? So you don't want to be doing, half of your equation in inches and the other one in, the rest in meters, because then you can't cancel things out nicely, cancel out those units. So you might have to convert from, for example, inches to centimeters. And so the way that you do that is you take your 15 inches and then you multiply it by a ratio of 1. Like, so this is 1, right? So there are 2.54 centimeters in 1 inch. So if you take, 5 divided by 5, that's just 1, right? So we're multiplying by a 1, right? But it's real fancy and clever, and it gets us to change our units, which is why it's useful. So this quantity is 1. That's why we can just multiply by it. We have not changed the number at all. And so when we multiply, by this 1, which is centimeters over inches, and then, they're correct, because there's exactly 2.54, well, not exactly, well, kind of. So there's more digits, but for argument's sake, let's just say it's exactly 2.54 centimeters per inch. Then you can cancel out these inches, and you're left with whatever your amount of inches is what amount of centimeters there are. So now you get to do it on your own. So I want to know how many seconds are in an hour. And then you get to vote. So just hold up a finger, 1, 2, 3, 4. Let's figure out how many seconds are in an hour. So, okay, so in order to figure out, if you're a little stuck, in order to figure out how many seconds are in an hour, you could think about it, how many seconds, or how many minutes are in an hour, right? So, oh, chalk. But that's fine. All right. So, I always forget this one has chalk. All right, so we have 1 hour, right? And an hour. And we want to know how many seconds are in it, right? So, let's not just jump right to seconds. You might know it off the top of your head how many seconds are in an hour, because sometimes that fact is just like something people pick up. But you might not. So let's say you don't know how many seconds are in an hour off the top of your head. Do you know how many minutes are in an hour? 60, right? So we could multiply by a ratio of 1, right? There's 60 seconds in an hour, or 60 minutes in an hour, right? So we could multiply by this little ratio. Right? So we're going to have 60 minutes on either the top or the bottom, and we're going to have an hour on either the top or the bottom. So how do we want to do it? 60 we want minutes on top, right? Because we want that to be left over. So we multiplied by a 1, right? And that'll get us to little unit canceling, and we'll have 60 minutes, right? Now, how many seconds are in a minute? 60. So we can multiply by another 1, right? So, which one goes on top, which one goes on the bottom? Minute's going to go on the bottom because we want it to end. So, and then we said it's 60 seconds for 1 minute, right? So then these will cancel, and you'll have 3,600 seconds. Is the same as an hour. So, answer is 3. I might have wrote this down. Yeah, I could have not written it. So that's how it goes, right? So it's this trick of multiplying by 1. Another idea I want to cover quickly, which you probably have heard in like chemistry or something like this, is significant figures. So experiments use statistics and propagation of uncertainty to determine how many numbers that you keep. We're not going to be we're not going to be running multiple experiments every time I give you a problem. So we're going to use, in order to determine how many numbers we retain, then we use this idea of significant figures. And so, for example, if we have 3 significant figures plus something with a whole shit ton of significant figures, then, does it really make sense that we'll have like 17.3 blah, 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 right? Like, this number isn't that accurate, so it doesn't make sense to like go out to like the umpteenth digit, right? So here you would just keep your 3 digits because you only know the first number to 3 significant figures. So, enough for quiz. Okay. All right, so